folks, sorry I'm not at school today, but lucky you, I'm going to do this flip lesson to kind of get you started on what we're doing and review a couple things. So make sure, if you haven't already, you grab one of these yellow sheets from the sub where we're going to be reviewing domain and range in 3 different examples. Some are easier, some a little bit harder. Make sure you take a look at it, at least try the first 2 independently before continuing with this video. So once you have some of this going, we're going to just continue on. I'm going to go over our very brief agenda for this video. This is the same presentation we would have seen if I was here today. So we're going to go over our sit and begin, which is domain and range problems. These are the hardest that these domain and range problems are going to be. They're not going to get harder than this, and you're going to see they're a little different than what we did last class because they have maximums and minimum values. So we're going to be writing 2 rules sometimes. After that, we're going to talk quickly about what standards are going to be on the test. There are going to be 5. In the past, I put 6. I took one of them off. Okay, the rearranging into different forms I did take off. And then you're going to have an ebook assignment that you're going to have to complete all those problems as your review before we take our test on Friday. On Friday when you come in, we're going to do 10 minutes of quick review and then hop right into taking that test. Just so you have an idea of what that will look like. If you remember back yesterday, today for the video, I told you in class that if you want extra help, I am more than happy to stay after school with you on Thursday. We can do a great review session so that when you come in on Friday, you're feeling really good. Just pop me an email and let me know. I already have a student staying after for standards, but I have no problem having a handful of people there to review for this test. I want you guys to do well and offer that support if you need it. All right, so let's take a look at that sit and begin with 3 problems on it. We'll start with the first one. A local youth group is planning a trip to an amusement park. They're going to take their church bus, which can hold 32 people, and it's going to cost $25 for parking and $22.50 per person. I know you folks could write an equation. The 2 pieces of information we would use for that are these 2, okay? But luckily they wrote it for you. Recognizing that this is $22.50 per person, they put it as our slope. And then 25 for parking, that happens once. That's going to be our y-intercept, where our cost starts, our initial amount. So here's our equation. It's written in function notation. C of n equals 2250n plus 25, where C is the cost to go and for parking, and n represents the number of people who are going to attend. Okay. So what is the domain and context is where we're going to start with this. So domain, hopefully in your head, you're like, okay, I know what you're going to say next. Domain goes with the x variable. Okay, so I'm going to keep that in mind. We're thinking of our x's. So we want to think in context of this problem, what is our independent variable? Or, and in this case, it's seen as an n. Okay, what does this n mean? So if we had 2250 per, which means multiply, person, that means we would do 2250 times the people. That means n has to be people because it's being multiplied by the cost. So x, our domain, in this problem is the number of people attending. Okay. Now, like we've spoken about for a couple classes now, I'm going to take that and I'm going to put it in set builder notation. So I'm going to start with my curly brackets, all the values of x such that. And now I'm going to think to myself, all right, number of people attending, what is the minimum and maximum amount for that? Because I want to think of what the limitations are for my domain. So, kind of big picture, kind of this specific situation. Hopefully you're like, yeah, Mrs. White, there's a minimum and it's 0 people. And you're right, there is a minimum. So I have x and I have 0. And if x is the amount of people going, the amount of people can be greater than 0 or equal to 0 because 0 is the minimum. But unlike some of our other examples that we've done, there's also a maximum in this problem. So take a second and read it again. The maximum amount of people that can attend is how many people are going to fit on that bus. You can't have more people than that. So the bus holds 32 people max. So the amount of people that can go, the maximum is going to also be 32. So you can have between 0 and 32 people. So I'm going to write the word and for now. I'm going to do x, and I'm going to do 32. Now my amount of people can't be greater than 32. It has to be less than 32 or equal to that 32. Okay, you can have 31, 30, 18. You cannot have 33. And there's my domain and context. Okay, number of people and my minimum and maximum written in set builder notation. Next, let's take a look at our range. So range, again, hopefully you're thinking, goes with the y. So Y is kind of our outcome piece here. And they told us that C is going to represent the cost for the group to go and park. So our range, our outcome is going to be the total cost. I'm going to start my set builder notation. All the values of Y such that. And I'm going to think, if people were to go to this event, what is the minimum amount it's going to cost them? So you might say $0, and I would kind of agree with you. However, it's $0 for people to get in to the park, okay? It's still going to cost money to park the vehicle. Now, would you go to an amusement park and hang out in the parking lot? Probably not. But if we're talking about 0 people for our domain, okay, then our range is going to be limited by 0 people. Meaning, if we put a 0 in for our X, we still would be paying for parking. Our minimum amount to spend is going to be 25. So I'm going to put Y and 25. Our cost is going to be greater than 25 or equal to it. Now, if that's our minimum cost, and we had a minimum amount of people, we're going to have a maximum cost because we had a maximum amount of people. Our maximum cost is going to be what we get when we plug this 32 into our equation and get it out. So, grab a calculator. Making sure to do order of operations, I'm going to multiply first and add second. So I'm going to take my equation, I'm going to plug in a 32 for n. So 2250 times 32 equals 720 plus parking, right? We need to add our y-intercept in there, $745. So our total cost is going to be between $25 and $745. Our cost is not going to be bigger than that. It's going to be smaller than the $745 if less people go, or it's going to be equal to it if exactly 32 people go. So this right here, ladies and gents, is as hard as domain and range is going to get, where there's a minimum value that you can't go underneath and a maximum value that you can't go above. Okay, we write that as 2 separate rules with an and in the middle. We're going to practice that more on this second example, okay? Joe has an after-school job at the local sporting goods store. He makes $6.50 an hour and never works more than 20 hours. The equation S of H equals 6.5H can be used to model the situation where H represents hours that he works in a week, and S would probably be like his salary, I think. That's what they would mean there. So this is my equation. I'm going to think, what is my domain in context? So first thing, domain goes with X. X is like this H value. If it's 6.5 per X, it's 6.5 per hours. X is hours. Now I'm going to start doing it in set builder notation, curly brackets, all the values of X such that, and now I need to think of my minimum, maximum, what's going on there, okay? So, what is the minimum amount of hours that Joe can work? 0, okay? Hopefully you're thinking that. If X is if 0 is a minimum, my X must be greater than or equal to it. And remember, he can work more than 0 hours or equal to it. Now, is there a maximum amount of hours that he can work in a week? Yes. In this whole situation, they tell us that he never works more than 20 hours in a week. So the maximum amount of hours he can work is 20. So I put the word and, X, and 20. Now, if 20 is a maximum, can our X's be bigger than 20? They have to be less than. Could he work exactly 20 hours? Yeah, he could. Equals. And close up our curly brackets. Lastly, we have range and context. Okay? So, range, we're going to look, what's this chunk here? This is how much money he's making. Okay? How much money he's making. So, money earned. It's range, so I'm going to deal with all values of Y such that, is there a minimum amount of money he earned? Well, if there's a minimum amount of hours, there's a minimum amount of money. So I think back to my equation. If he works 0 hours, what would his pay be? Not $6.50. 0 times 6.5 is 0. So if he works 0 hours, he's going to make 0 money. His money earned has to be greater than or equal to 0. Now, again, if there's a maximum amount of hours, there's a maximum amount of pay. Okay, he's not going to get paid more than what he would get paid for $20 for 20 hours. So I'm going to do $6.50 times 20. And I get $130. So I'm going to put and the amount of money he makes, which is Y, must be less than or equal to the maximum of $130. He can make less than 130 or equal to it, and he can make more than 0 or equal to 0 if he doesn't work at all. Now this last problem is trickiest because they don't give you the equation. So let's take a look at that one. Levante decides to start a business by printing designs on shirts and selling them for $25 each. In fact, writing this equation is pretty challenging. The printing machine costs $1,000 and materials for each shirt cost $750. Levante is interested in calculating the profit of her business. Profit is defined as revenue, which is money coming in, minus expenses. To get started, she orders 500 t-shirts. So, in this problem, the trickiest part is determining the slope, okay? You might be saying to yourself, it's not tricky. She's getting $25 per shirt. You are right. You might say, Mrs. White, that's not the slope. She has to pay, which would be negative, $750 per shirt. And you're kind of right, too. What we need to do for our slope is keep this in mind. We have money coming in, and we have money that has to go out with every shirt. So we can model that with the slope. Our slope is going to be the 25 that you get in and the $750 that you have to pay out per shirt. So our slope is going to be the difference between those two. So 25 minus $750 is going to be $17.50. So this is going to model her profit, okay? After she takes the money in and pays for stuff, that's how much she's going to be left with per shirt, okay? So y equals 17.50x. And then where does she start her business at? Well, she has to buy the machine, right? It costs $1,000. Are we going to add $1,000 to her profit? We're going to have to subtract $1,000 from her profit. So here's the equation that models this situation, okay? Y equals $17.50 per shirt minus the cost of the machine, $1,000. So let's talk domain, all right? Domain is our x's. We just said $17.50 profit per shirt. X has to be shirts. And more specifically, it's shirts sold, right? Not how many she makes, but how much she's selling. So all the values of x such that minimum amount of shirts that she can sell, 0. So our shirts must be greater than or equal to 0. Now, at this point in the problem, I'd say maximum, and you would probably say there's no maximum. She can sell a bunch, but they gave us a lot of information in here. There is a maximum amount of shirts she can sell. It's 500. Okay? Read the problem for the rest of the information. So, x must be less than or equal to 500, because she can't sell more than what she has right now. I get internet stores, I get there's a lot of other reasons, but based on the information provided, that's our maximum and that's our minimum. The range goes with our y, so I'm thinking about this. So if I have the amount she makes per shirt minus the cost for the machine, that's her expenses, I could say that y represents total profit, okay? It's how much money she's taking in to put her in the green, and she still has to pay off that machine. So profit, you could say money. I would be okay with either of those. Total revenue, that would work too. So all the values of y, because we're dealing with range, such that, is there a minimum profit she can make? Yes, it's not $0. Okay? Again, you have to kind of go back to this situation. If she sells 0 shirts, she's owing $1,000, right? So negative 1,000. So you're like, okay, that's it. That's actually not it. She already ordered 500 shirts. She already has to pay for this. And she has to pay for this. So she's got to pay for the machine and the 500 shirts. So to figure out our minimum amount of profit, it's going to be the cost, $750 per shirt. So 500 times $750. Just those shirts cost her $3,750. And she still owes $1,000. So I'm going to add $1,000 to that. Holy cow, she is negative right now. $4,750. Because she paid for these shorts. She already ordered them, so she has to pay for them. And she has to pay for that machine still. Now, we took care of this $750 here when we wrote our equation, but we still need to take it into consideration when we are dealing with our ranging context. Okay? So, Our y values must be greater than or equal to this. Hopefully she makes some of that money back. Okay, that's pretty expensive. Now, if there's a minimum amount of shirts sold, minimum amount of profits made, there's a maximum amount of shirts sold, maximum amount of profit made. Okay? So if she sells all 500 of those, I'm going to take that 500 and plug it in here. So 1750 times 500 equals plus, oh, just kidding, minus, because she had to pay for it, $1,000. Her maximum amount would be $7,750. So her profits could be less than that or equal to it. Okay? This is harder than the ones you're going to see on your assessment, but if we practice harder, the easier ones will feel a lot easier, okay? Again, they have a maximum and a minimum values. If it happens in your domain, it's got to happen similarly in your range, and you might have to calculate some stuff, okay? So, keep this sheet somewhere safe. It's a good thing to review for as you're getting ready for Friday. I will do one more problem on Friday before you take your test, just to refresh your memory a little bit and make sure any questions you have are clarified. So, let's move on. On your test, you're going to be asked to write linear equations from a graph, from a relationship, which is a word problem, and from 2 points, okay? This whole situation represents 2 standards. These standards were covered on your quiz already. This, rearranging into these 3 forms, were on your quiz. However, they are not on your test. You're welcome. I thought that that would be one thing that we could take off, that if you've already practiced it and shown me you know it once, it's not as important as some of these other things. Okay. Next, you have line of fit for scatter plots, where you make your little scatter plot. You pick 2 dots that model the data well. Okay. That is its own standard. Interpreting domain and range with limitations and set builder notation, that's what we just talked about. That will be on there. And then lastly, last class, when we looked at all those different pizza places and stuff, we compared linear functions represented differently. Okay, so we looked at them in a graph, a word problem, and we compared slopes and y-intercepts and figured out what was the best deal. Well, you're going to have one of those problems on here also. So to practice some of these skills, there's an ebook assignment that I want you to do. And it's actually a little different than this. I'm going to have you do 10 through, I think it's 30, on page 273 to 274. Then I'm going to have you skip a whole section, okay? So you're going to see a section that says rearrange into standard form, rearrange into slope-intercept form. You do not have to do that, okay? You do not have to do that. You're going to skip down to the section that says parallel and perpendicular lines and then line of fit. So this, I believe it's going to start back up. I'm not exactly sure. I believe it's in the early 40s, mid-30s. I don't know, but you'll be able to tell when you look at the ebook, okay, that which sections you're going to have to do. So just to show you what that's going to look like, you're going to need to do 10, which is, this is a screenshot right from your ebook. Okay, I don't know if it'll let me drag it down. This, okay, is right from your ebook. You need to do this whole section. Below, you need to do this whole section. When you go to the next page, okay, you're not going to do that whole section. You're only going to do 28, 29, and 30. Then you skip 31 through 38. I'm taking that whole standard off your test. It's important that you know it. If you passed it on the quiz, you're already good to go, okay? Then we're going to see parallel and perpendicular. Remember, parallel means same slope. Steal the slope and plug in your x and y to get your new b. And perpendicular lines, those are opposite reciprocals, opposite signs, so negative to a positive. And then reciprocals, flip your fraction. There's a few of those. And then the last section is line of fit, so 47 and 48. So you're going to skip, again, 31 through 38 and pick it back up at 39. Okay? Again, on Friday, we will do 10 minutes of review. I'm after school Wednesday and I'm after school Thursday, so please contact me if you need help. But don't just say I need help. Make an appointment so that we can get together and discuss things before your test. Again, as always, I'm here for you. Just let me know. And your homework for the rest of class that you can get started on, maybe even finish, is going to be this assignment in the ebook. Thank you, folks. I will see you Wednesday maybe after school, Thursday after school, or definitely Friday morning. Thanks.